And so we're going to try and finish this. So now we had started talking about how difficult or easy it is going to be to remove electrons from an atom, which is ionization energy. And we had discussed the first four factors which affect the ionization energies, and those were, you had your number of protons. They're the ones that are attracting electrons. The distance, the shielding effect, the net positive charge on an atom, which is different from the nuclear charge. The net positive charge includes the charge of the electrons as well. So it's the overall charge on the atom. And there's a fifth factor, which is at the moment not that important. It's because it doesn't always come into play, and that fifth factor is the subshell. It's the subshells and orbitals that usually doesn't matter. So this factor only plays a role in certain instances. Otherwise, it doesn't really matter which subshell you're removing the electron from, whether it's the S subshell or the P subshell. It doesn't really matter. The distance and the shielding are what are more important. The nuclear charge is more important. The net positive charge is more important, but subshells, it only plays a role in certain cases. So remember these five factors. We're going to revisit those five factors. Mainly it's the four factors. The fifth one, not always a factor. The first thing that they're going to ask you about is it's going to be about definitions. Definitions for ionization energies. That's the very first, very basic thing that they will ask you about. So for example, they're going to ask you what is the first ionization energy of an atom. So I'm just writing I dot E. So first ionization energy is the energy that is needed. It's always an endothermic process. So it's remember this, it's always going to be endothermic. To remove 1 mole of electrons, from 1 mole of gaseous atoms, so 1 mole of gaseous atoms to form 1 mole of gaseous +1 ions. So gaseous +1 ions, and measured under standard conditions. So this is a definition that you have to remember by heart. They're going to give you a 2-mark question on this. So remember, you're trying to remove 1 mole of electrons from 1 mole of gaseous atoms, and you're going to get 1 mole of gaseous +1 ions. So that is first ionization energy, and they're going to ask you about an equation for that as well. So for example, they might ask you write down the equation or represent this information in the form of an equation. So first ionization energy of let's say calcium. So that is going to be, you're going to take a calcium gaseous atom, and what you're going to do is you're going to remove 1 mole of electrons from it, from 1 mole of gaseous atom. So you'll get 1 mole of gaseous +1 ions, and 1 mole of electrons are going to be produced. Okay, is this clear to everyone? Is this clear? Mikal, Munib, is this clear?
Yes. Yes, sir.
So basically, you're just trying to remove one more of electrons. It's always going to be endothermic because it's always going to be difficult to remove electrons. You would have to. The electron is always sticking to the nucleus. So it always requires energy for you to pull that electron out of the nucleus. So that is first ionization energy. And they might ask you about the second ionization energy as well. So the second ionization energy is going to be exactly the same, except what you're going to do now is, in second ionization energy, what you're going to do is, you've already removed the first electron. So now you will try to remove the second electron. So if I start off with calcium, but calcium would be 1+ now. The first electron has already been removed in the previous step, which is the first ionization energy, and now I'm trying to remove the second electron. So that would be, so I'm still basically removing one electron, but now it's the second one. The first has already been removed. If they ask you for the definition, all you have to do is just copy paste the first definition and just change that definition a bit. So the definition would be almost the same. So it would be the energy that would be needed to remove 1 mole of electrons from 1 mole of
gaseous
gaseous.
ion, sir.
ठीक है, बस ये change
One
होगा.
positive ion.
So it's going to be gaseous plus 1 ions to form 1 mole of gaseous plus 2 ions. So that's it. So basically, so that's second ionization energy, and similarly you'll have the third and the fourth and the fifth, etc. So for example, if I were to write just the equation, the fifth ionization energy of calcium, so that means 4 electrons have already been removed. So if I were to write an equation, so 4 electrons have already been removed, I'm trying to remove the fifth electron. So this would make it into calcium, this would turn it into calcium plus 5. Plus 1 electron. So calcium is going to have a total of 20 ionization energies because you can remove 20 electrons one by one after the other. Sodium is going to have a maximum of 11 ionization energies because it has 11 electrons. So you can continuously remove electrons, and these would be your equations. Can anyone tell me what, in terms of ionization energy, how do you describe this? I've got aluminum gaseous, and I'm trying to remove, I removed 3 electrons.
This is the fourth ionization energy of so this is the third fourth ionization energy of aluminium.
Yeah, it's the
Fourth ionization energy of aluminium.
in the fourth. I should remember one thing you have to remember is that the way you can figure this out is if it's the second one, so the ion that is going to be formed is going to be 2+. If it's the fifth one, the ion that's going to be formed is going to be 5+. So what ion is getting formed? Let's say any one.
3.
This is so T. That's I said. Now remember one thing. This is just a trick question. It's actually, remember, this is not the third ionization energy, because if it's the third ionization energy, then 2 electrons would already have been lost. I mean, this would have started at 2 plus. So what's happening over here is you're removing you're removing 3 electrons from aluminium. So you've removed the first. You've also removed the second one. And you've also removed the third one. So this one is the first plus second plus the third ionization energy of aluminium. So it's all three combined together. Because remember, if you had just removed the first one, it would have formed aluminium 1 plus. If you had just removed the third one, then you would have started at aluminium 2 plus, and then you would have removed the third electron. So what is happening here is you start at aluminium, and you remove the first electron, it becomes aluminium 1 plus. Then you start at aluminium 1 plus, and you remove the second electron, and that would turn it into aluminium 2 plus. And then you start at aluminium 2 plus and remove the third electron. So you end up with aluminium 3 plus. Every time you're removing 1 mole of electrons. So if you start at aluminium and you end up at aluminium 3 plus, so you're basically doing 3 ionization energies. The first plus the second plus the third one. Is this clear, this one?
Yes.
Yes. So, sir, the answer would be 3E, right?
The answer would be?
What would the answer be?
If you want to describe this is the first plus the second plus the third ionization energy. Like it's the sum of all of them.
Yeah, okay.
Because you can't call it the third one, because the third ionization energy, you just remove 1 electron, but the third one, 2 have already been lost, and you're trying to remove the third one. Is that clear?
Yes, sir.
And
Yes.
there's certain questions which come similar to this. 1 second, let me just quickly so just very quickly, just wanted to show you that there would be certain questions which would be where they would play around with this. Just a second. Firstly, although this one is a straightforward one, which one is the second ionization energy of an element X? Which equation is the correct one? The second ionization energy.
B.
B.
Okay, so it's going to be B. 1 electron has already been lost. You're removing the second one. So your starting point is +1, and now you're forming 2 plus. But let me just find this one. This one is these two questions. So he's saying, although this one, the value of the second ionization energy of calcium is 1150. So which equation correctly represents this statement? So again, second ionization energy. So which one is the correct one? And is it going to be plus 1150 or minus 1150?
Plus.
Okay, remember it's going to be endothermic.
So it's going to be A, right?
He's talking about just the second ionization energy.
Oh, okay, then it's going to be B.
So it's going to be B. This one is talking about, so it's going to be B because you've removed the first one and you're removing the second one now. So your starting point is +1. Similarly, this one, you third ionization energy. So which one is the correct one?
D. D.
TKD. And also remember the states, it has to be gaseous. So D is correct. 2 electrons have already been lost. You're moving the third one now. So it's +2 740. Just hold on 1 second. There was one. I don't know where it went. Just a second. Yes, probably this one. So he's saying, what is now this one? This one is the tricky one. So he's saying what is the second ionization energy of sodium? So I mean, we can obviously write the equation for that. The second ionization energy of sodium. So sodium's first electron is already lost, and you're removing the second electron, right? So it becomes 2+ now, and so we know that's the second ionization energy. Now describe that in terms of W, X, Y, and Z. Yes, Hamza.
Would it be X minus W? Because the first two, they're in gaseous form. They have the elements in gaseous form.
So I guess it's going to be, I mean, Hamza, did you raise it again? Just a second.
Oh, sorry. No.
Achha,
My
theek.
mistake.
Achha, so what is X? X is, I mean, it can't be in solid. Ionization energies are not for solids, right? It's always for gaseous atoms. Now, what is X? X is the first plus the second ionization energy. Because if you look at X, it goes from sodium neutral to sodium 2+. So that means 2 electrons are lost, the first two. The first is lost and the second is also lost. So you're removing 2 electrons. So it's the first plus the second. And what is W? W is only the first ionization energy. You're just trying to remove the first electron, that's it. So if you're trying to find out the second ionization energy, what you have to do is subtract X from W. X is the sum of the 2 ionization energies, and W is just the first ionization energy. So if you remove the first ionization energy from X, you're only left with the second one. So it's going to be B. Is this clear?
Yes.
Yes.
Okay, so just remember, don't get confused. It's a very basic thing, but don't get confused with this. And maybe there was, we'll forget this. We'll do those questions later. So you have to be good with writing these equations. And Ali, clear tha? Last. Just so next is, now we're going to start discussing those factors that we had listed above. And the first thing that we're going to discuss is the successive ionization energies. I'm just writing I dot E. I mean, in your exam, you have to write the whole thing. So successive ionization energies, what that means is you're successively trying to remove electrons from an atom. So it's the successive removal of electrons from an atom, from the same atom. So for example, let's pick the magnesium atom. Now it's got 12 electrons and it's got 12 protons. So the 12 protons are in the nucleus. It's a positive 12 nucleus, and that's holding or pulling all the electrons. It's got 3 shells. So here's your third shell, and it's got 12 electrons. So it's the electrons are 2. Then you've got 8. And you've got 2 electrons at the end. So you're trying to one by one remove all these electrons. That's what you're trying to do. So magnesium in total is going to have a total of 12 ionization energies. Just let me, so that's 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So you can basically remove 12 electrons from it. So I'm trying to remove the first one. Now, relatively speaking, is it going to be the easiest to remove or the most difficult to remove?
Easiest.
Easiest.
Okay, so that one is going to be the most easy one because lots of factors in play because it's really far away and it's very shielded. The nucleus over here and the electrons, lots of inner shells coming in the way. So it's very far away. So it's going to be the lowest ionization energy. So this axis over here represents ionization energies. Now removing the second electron is also going to be kind of easy, but would it be more difficult compared to the first one or easier compared to the first one?
So easier.
More difficult.
It's actually going to be, yes, it's exactly going to be more difficult. Slightly more difficult, just very, very slightly. Not a drastic increase, but it's going to be slightly harder. And does
So
even
won't it be easier, sir?
नहीं,
क्योंकि एक ही electron है.
देखो, we removed the first one, TK, we got rid of the first one, TK. Now we're trying to remove the second one. You're trying to remove the second electron and it just slightly becomes more difficult. What's the reason, Rima? What's the reason for that?
Because less shielding effect.
Which one?
So can we say this that in the first while removing the first electron, there was also a repel from the remaining electron. So can it play a factor?
Because there are less electrons now, so the nucleus will pull more.
Okay, so it's because of the yes, exactly. So it's because of the net positive charge. Ali, is this clear? Okay, now there are actually less electrons.
Yes, sir.
Ali, your point was actually clear. That is what net positive charge is. I mean, one of the factors that we discussed. These net positive charge was the total charge of the nucleus plus the charge of the electrons as well, right? Is that clear?
Yes, sir.
So you can combine all of the effect as net positive charge because now the distance is the same, the shielding is the same, the number of protons are exactly the same, but the net positive charge is now +1. So this electron over here is going to be more strongly pulled by the nucleus because there are fewer electrons repelling it. Okay, so it has an overall positive +1 charge. Now you've removed the second electron as well, and now every time this happens, the positive charge continues to increase. What about the third electron now? What would happen with the third electron?
There would be a great increase.
Okay, so removing the third electron, there's going to be a pretty big jump. And the reason for that jump is, I'm going to write the reason, I'm going to ask you for the reason. So whenever the shell changes, what happens is that the distance decreases. So all of a sudden your electron is a lot closer to the nucleus. And also it's less shielded. There are fewer things coming in the way between the nucleus and your electron over here. So if you're trying to pull this electron out, it's going to be more difficult. So your distance and shielding both decrease. And this jump indicates that the shell changes.
Sir, can you are doing with this with the electronic configuration? Can we do it with like the 1s2, 2s2 electronic configuration? These kind of questions.
You can do this, but I told you that that the type of subshell it's not that big of a factor. Like if you're removing electrons from the 2s spherical orbital or you're moving electrons from the 2p, which is dumbbell shaped, it's the distance and the shielding that really matters, not
Okay, sir.
not the shape of the orbital. So it doesn't really matter whether you're removing it from an S and P. It will matter. Okay, it will. This fifth factor is going to matter, but it only plays a role in certain very specific cases. Otherwise, it doesn't really matter whether you're removing it from a spherical or a double-shaped orbital. Okay, is that clear?
Yes.
Yes, sir.
Yes.
So what about now you're removing all the other electrons from the second shell. So the ionization energy would, I mean, the distance and the shielding are the same, so it's not going to be that much of a difference. So you're moving the third, the fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So up till the 10th one, so this is third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So up till this point, there's going to be just very, very gradual increase in ionization energies because the distance and the shielding are the same. And then when you try to remove the last two electrons, that's going to be difficult. So there's going to be a big jump when trying to remove the last two electrons. So when you're trying to remove the last two electrons, there's going to be this jump once more. So just let me. Okay. So this is 1, 2. th and 12th. So this is how magnesium's ionization energy is. This is a rough sketch. It's not. I mean, it's not going to be exactly like this. There's going to be some fluctuation. It's not going to be a straight, perfect line. So it's a rough sketch. So remember, there's going to be a jump whenever there's going to be a shell change. And why do the ionization energies continuously increase? Like even if you ignore the jumps, it is always constantly increasing, and the reason is that the net positive charge continuously increases. So it increases continuously, but there would be massive jumps whenever there's going to be a shell change. So is this clear?
Yes.
And we can use this to sketch. It's going to be pretty simple to sketch these curves for different elements. So, for example, if I have fluorine, so fluorine has a total of 9 electrons. So fluorine is 2 in the first shell and 7 in the last shell. So if I were to sketch this for fluorine, it's going to look like this. Let me just copy this quickly. Just 1 second. So if I were to do the same thing in the case of fluorine, where would the jump happen?
On the
After
eighth,
the
Sir, after the second electron.
yes, after the
Second?
After the seventh electron, sorry.
Seventh. So the first 7 there's going to be a gradual increase. And when you're trying to remove the 8th one, there's going to be a very, very large increase. There's going to be little difference between the 8th and 9th. But this is how the sketch would look like. That's how fluorine would look like. And on the same sketch, we can have some other element like, let's talk about sulfur. So sulfur has 16, so it's 2, 8, and 6. So if I were to plot sulfur over here, for sulfur, I would need the 13th, 14th, 15th, and the 16th. So how would sulfur look like? Sulfur would look like Where's the jump going to come for sulfur?
After 6.
Okay, so it's going to be after 6. So sulfur would go up till 6. And at the 7th one, there's going to be a jump. And from the 7th till what number? Like you're removing electrons. So it's 7, 8, 9, 10, 11, 12, 13, 14, up till the 14th. So 14th would be till this point. So up till the 14th, it's going to look like this. And then the last two. There's going to be a jump again, and then the last two. So sulfur's sketch, rough sketch would look like this. Its shape would be like this. So this is sulfur, and this is, the blue one is fluorine. And so just remember, the electron removal starts from the outside. You get a jump, then 8 electrons removed, then there's another jump, and then 2 electrons removed. So is this clear? This whole thing?
Yes.
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 So the next question is, what information do you get from this sketch? Like if you didn't know, like if I just hit this, I mean, if I just had this graph, like I had a random atom, I didn't know it was sulfur, I didn't know it was fluorine. What information could I get from this? Can anyone tell me one information? Like, I mean, you can get a lot of information.
The group number.
Okay, so number 1 is your group number. So you can tell the valence shell electrons. And you can tell the group numbers. Which group
And number of shells.
You can also tell the total number of shells. Like, I mean, every jump means there's a shell change. Like every straight line, that's one shell. That's another shell. That's another. I mean, every relatively horizontal line is one shell. So you can tell the number of shells. The total
number of electrons, maybe.
Okay, that's also true. And now the most important thing, which the information that you remember, they're going to ask you questions indirectly. So when you get this information, you can tell a lot of properties about an atom based on where it's located in the periodic table. So if you know the group number, if you know the shell number, you can go and identify the element, right? For example, by just looking at this, what you'll get is that it's got 3 shells. So if you know the number of shells, you can also know the period number. So if you're given this graph and you're being asked to identify this element, so you know that's shell number 3, and it's got 6 electrons in its valence shell, so it's group 6. So it's group 6 and period 3. All you have to do is you just have to open the periodic table, and you'll be able to. So just remember, 3 shells, period. That means period 3, and group 6. So that's all you have to do. That's 1, 2, 3, and it's group 6. So it's going to be sulfur over here. So you can easily identify the element by just looking at the diagram over here. This is 2 shells, so that period 2, and it's group 7. So it's group 7 and period 2. So that's this is period 2, and this is group 7. So that's fluorine. The other more important thing about this is that if you know the group numbers, you can pretty much tell a lot about the properties of the atom. You can tell whether it's a metal or whether it's a non-metal. You can figure out the number of chemical bonds it's going to form. You can also figure out the ion that it will form. Like if you know that this is sulfur, it's in group 6, so you know it's going to form a -2 ion. So a lot of properties can be found by just looking at the group number. So they'll ask you a lot of indirect questions about these elements by just giving you a sketch of the successive ionization energies. So is this clear?
Yes.
So for example, I'll just for example, I'll just make a rough sketch of another element, and this element looks so it's something like this. It's as a first thing, what would be its formula with hydrogen? Let's call this element X. Like what compound would it form with hydrogen?
XH4.
Why H4? Which group is this in?
Sorry, it's in group 5. So XH5.
If it's in group 5, it needs 3 electrons. So it's only going to form 3 bonds.
Okay.
Okay, so remember this, that if an element is in group 5, it needs 3 electrons to complete its outer shell. So it would just need 3 hydrogens. Each hydrogen would give it 1 electron, share 1 electron. So this is XH3. It's going to form XH3. And this is basically, and if you were to identify this element, it's going to be period 2 and group 5. So this is period 2 and group 5. So period 2 is this one. Group 5 is this. So it's basically nitrogen over here. And a lot of times they're not going to give the, sometimes they're not going to give the whole sketch, just a partial sketch. But hopefully everyone gets this idea. Now, so remember, that's the first thing, successive ionization energies. Does anyone have any questions? Is this clear?
Yes.
Now, the next thing that is going to be discussed is a comparison of elements and their ionization energies. So it's the comparison of the first ionization energy down a group. And remember, it's only the first ionization energy. So you're just trying to remove the first electron. So just the first one. Now, if you're trying to remove the first electron, it's going to be like if I take any group, it's going to be kind of the same. So for example, I've got group 1, that's lithium. And then after lithium, I have sodium. So when you move down the group, the number of shells, they continuously increase. So it's got 1 extra shell. Then after sodium, there's going to be potassium, and potassium is going to have just 1 more extra shell. So here are your 3 atoms. So quickly, the first one has 3 protons. The second one has 11 protons. And potassium has 19 protons. And the number of shells, they continuously increase. The number of electrons also increase. So the first one just has 3 electrons. The second one has 2, 8, and and 1. And the third one has how many? 19 electrons. So it's 2, 8. And another
281.
Okay, so quickly tell me, is it going to be, and you're removing the first electron, only the first one, not all of them, just the first one, and you're comparing them. So for which one it's going to be easy, for which one it's going to be difficult?
The easiest will be the
Sir, I
last
think
one.
it would be the easiest for the first one.
Or Rima, what did you
First
say?
Because
one,
It'll be the
fraction of-
hardest for the first one.
Okay.
yes, it will be the hardest for
So
first one.
it's going to be the hardest for the first one. Why? Because the electron is very close to the nucleus, so the distance is very, it's very close.
small atomic radius.
And for the last one, it's going to be really easy because the electron is really far away and it's very shielded as well. The nucleus cannot really attract the electron because it's very far away. Plus, there's lots of other electrons coming in the way. So I'll just quickly sum this up. First, ionization energy decreases down the group. In any group, it's the same trend. It decreases, and you have to remember this. You get a very typical question on this, which is exactly this. They just ask you to compare the first ionization energy down the group. So the first mark would be for that it decreases down the group. Why does it decrease? Because
So would this be the same for every group?
it's going to be the same for every group. So because distance and shielding, or you can call atomic distance, you can replace it with atomic radius. Distance and shielding effect increases. There's one factor that actually goes against that. What is that one factor?
The shielding? Sorry, the nuclear charge?
The nuclear charge is the one that's actually going against that, because two of the factors support that the ionization energy should decrease. The electron is becoming further away and more shielded. So ionization energy should decrease, but at the same time, the number of protons are increasing. So the attraction should increase. But because of the two factors being more dominating factors, overall effect is that it becomes easier to remove electrons. So ionization energy increases down the group because distance and shielding effect increases, despite the fact, so you always write this extra point, which is, so this happens despite the fact that protons or nuclear charge increases. So always mention this third factor as well, which is going against that. So despite the fact that nuclear charge increases, so electron removal always becomes easier. So this is the 3 or 4 mark question that you typically always get about elements and their first ionization energy comparison down the group. It becomes easier. The electron is further away, more shielded. So it becomes easier to remove electrons, but despite the fact that the protons are increasing. So is this clear?
Yes.
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 So there's a third one which we'll do tomorrow now, which is the comparison of first ionization energy across the period. And then we'll do past papers on this. Okay, so let's continue tomorrow now.
All right, sir.
Sir,
Okay.
Hanji.
Thank you.
Okay, take care. Allah Hafiz.
Okay, Allah Hafiz.
Hafiz. Ali, question है?
sir, yes, sir, पहली बात तो ये, sir, is there a class on Saturdays and Sundays?
नहीं, सैटरडे को होगी अब.
और संडेज को नहीं होगी?
हाँ, मुझे कोविड हुआ था, मैं अब जाके रिकवर हुआ.
सर मुझे मामा ने अभी बताया थोड़ी देर पहले.
हाँ, वो अब मैं ठीक हूँ, वरना उसकी वजह से ना मैं थोड़ा डाउन ही
और
था.
संडेज ऑफ होंगे.
हाँ, सैटरडे को अब रखेंगे क्लास, ठीक है.
ओके. और सर दूसरा सर, जो आपने कहा था मुझे इक्वेशन से कराएंगे, वो सब चीजें कब होंगी सर?
हाँ, इक्वेशन वाला है कि इसमें इसके बाद हमने मोल्स ही करना है ना, तो मैं
अच्छा, ठीक है
मैं तुम्हें अभी वैसे भेज देता हूँ, ठीक है, वीडियो लेक्चर्स ना।
ठीक है सर।
देखिए इसके बाद मोल्स करना है, तो इक्वेशंस तो फिर से करनी करेंगी हम, तो लेकिन वो मैं स्टार्ट कर देता हूँ थोड़ा सा ना, मैं भेजना भेजना शुरू कर देता हूँ, ठीक है।
ठीक है सर,
चलो ठीक है, ओके,
थैंक यू सर।
हाफिज।